Hello and welcome in. Mark here, aka the Markster. This is video number 34 in the FreeCAD series. Today we're going to be making a dodecahedron, which is one of those platonic solids. There are 5 such solids. Let's go here to the Wikipedia page on regular dodecahedrons, and I'll show you. Here's a model of it, and you can see how each face is a pentagon, and there are 20 faces. So one way we could make this would be to start off with a pentagon and add another pentagon to each of these faces adjacent on each of these edges, and then sort of fold them up. But what angle would that need to be so that all the vertices meet together? So that's the reason I got on Wikipedia to try to see if there was some information on here and the dimensions for those angles. And as I was browsing through this, I came across the Cartesian coordinates for the vertices, the 20 vertices. You can see them here, and the orange ones are all at plus minus 1, 1, 1. Those are the orange ones, and the green and blue and pink and so on. So I said, well, this is a way that we can make this. I can write a little macro script and show you how to do that, and then we'll use these points to create the datum planes, and we'll map sketches to those datum planes. So it's an opportunity here to show you a few different things. So let's go into FreeCAD now, and I'm going to go to the macro menu, macros, create a macro, and we'll call this dodecahedron points. Alright, so now we're in the macro editor, and we're going to start writing a little macro. Now I use Visual Studio 2017 to do a lot of the stuff that I do. So I'm going to actually use that for the coding part, and we'll be making these points just like if we were using this tool here to create a point. So you see the vertex object. If we look down here in the Python console, you'll see how this was done. app.active document add object for vertex, and it set each X, Y, and Z to 0 in this default vertex. So that's what we'll do to create the vertices. Let me get Visual Studio 2017 up, and I'm going to open that file, that same file that we just created, and it's dodecahedron points. Now Visual Studio 2017 is a free version. It's the community edition. You can download that free from Microsoft. Just do a search for Visual Studio 2017 Community Edition download Should bring you right to it. You download the installer, which is a fairly small file, probably less than a megabyte, and that file will install and download the other parts that it needs. So what I would recommend, if you're going to do FreeCAD Python work using this, what I did was I just selected everything that had Python as an option. Iron Python, whatever it said. If it had Python, I clicked on it. And what you need to do is probably rename your file .py extension so that Visual Studio will recognize it as a Python file. There's a setting in here somewhere where I was able to add this FC macro extension so that it recognizes these files as Python files. I don't know exactly where that setting is at the moment. So you can rename this with a .py extension. FreeCAD will recognize it and work with it just fine. And Visual Studio will see it as a Python file too. So go into the debug menu and we select attach to process. And here in the attach to section, it needs to be Python code. So you can select the different types and just select Python if it's not already there, and it probably won't be. And then we just look for the FreeCAD executable and attach. So now we're attached to the FreeCAD executable, which was already up and running. And we can begin coding right here in Visual Studio. So the first thing I'm going to do is I'm going to import FreeCAD. And I'll say from FreeCAD import base. We need base because base.vector is what we're going to use to create the vectors. The list of vertices is going to be a list, so we'll create that blank list. And this is going to be a list of FreeCAD.base.vector objects. So I'm going to make a little shortcut here. V equals base.vector. Just a little typing shortcut. So now instead of saying something like V equals base.vector XYZ, I can just say V equals V XYZ. So this is just a little shortcut for being able to do that little trick. And let's see, what else we need is to import math. I think we'll probably be using math.square-root. And we need a method for adding those coordinates that we found here in Wikipedia. We need to be able to add these to our vertices object. So we're going to define a little method here, def space, I'm just going to call it add v, and enter the colon. Now in Python, we determine the scope of a loop or a function using indentation. So we're going to use 4 spaces. 4 spaces. You can use tabs or spaces, but you cannot mix them in Python 3. It was allowed in Python 2, but it's not allowed in Python 3. Okay, so we're just gonna use the vertices as a global and not pass it in as a parameter. So it's gonna say vertices dot append V. I think that's all. I think that's all we need for that. And now, let's look again at this. So we have 20 vertices. Some of them use plus or minus 1, 1, 1. Some use 0, plus or minus phi, comma, plus or minus 1 over phi. Now phi is what this little symbol is the golden ratio, which is about 1.618. So it's 1 plus the square root of 5 over 2. So let's do it from here, up here, and we'll say phi equals 1 plus the square root of 5 over 2. 1 plus math dot square root 5 over 2. So that's phi. And I also want this to be kind of, you see it was modified in here, and when I click on it, I get all my additions here in FreeCAD too. I want this to be parametric, to be able to scale it. So I'm going to go to dynamic data, create a new DD object, and add a variable, and call it a float type, and I'm just going to call it scale, and I'll set the initial value to 1. So this will enable us to scale these vertices using the scale property. But I need to be able to refer to that scale property. So I'm going to say scale equals app.activeDocument.dd scale, and I think that's going to give us the scale. I'm going to create that object here. Let's see. And then we'll say v.x times equals scale. No, I'm not going to do it here. I changed my mind. This is a work in progress. All right. Let's test and see if scale is working like I'm expecting it to. So what I've done here, this little red dot, when you click over here, that's a breakpoint. So the code's going to execute and it's going to stop right here. And we run it in FreeCAD. Now you have options here to debug or execute. We're just going to execute. The debugging will take place in Visual Studio. Feature Python object has no attribute DD scale. Well, I'm gonna right click here. Well, let's right click here and choose send to Python console. So now obj equals that object. Obj dot, and let's see if we can see DD scales to capital S. So that was what we need here, capital S. Alright, and clear this error out and run it again. Enter pass here. Let's put it down at the bottom of this definition. And we'll put our breakpoint on this. Let's see now if we can get a breakpoint to stop here. Alright, so now we're broken in. Now at the bottom here you see I have locals. These are all the local variables available, including the add function, including v, including scale. But that's a lot of stuff to have to kind of look through. So what I like to do is use the watch window. If you go into debug windows, you can select the watch window to show autos and locals and lots of different windows in here. So the watch window, we can enter scale here, and it lets us see that scale equals 1.0. So we have successfully pulled in that scale value from the DD object. In the immediate window, you can enter things in here. For example, I could say scale equals 3.14, and now check the watch, and you see that the value has changed. So if you have some code running and you want to make some little minor modification, and you don't want to have to stop it and restart it, you can add it into the immediate value and then continue running. So that's a really handy window to have available. So we're going to continue, just let it run on through. So we're looking pretty good so far. Now let's see about adding in these coordinates here. So we need 20 of them all together. +1, +1, or -1, -1. So this is 2 possibilities, 4 altogether. Now 2 times 2, and then 8. So this will give us 8 different permutations that we're going to need to code in. And I'm just going to do them manually. So I'll say add one, 1, 1 as the first one. So I'm gonna need to make a few little changes here. Let's see. Let's change this to X, Y, Z. And here will be V, X, Y, Z. How about that? I kind of make this up as I go. So that's going to work. And now add 1, 1, -1. So notice I'm going to go from right to left where I made a change. And next one will be add 1, minus 1, 1. I had a visitor there. So the next one is going to be add 1, minus 1, minus 1. So you see how I'm doing it? I'm trying to avoid skipping any and try to be methodical. We'll start at the right side and work our way over. And the next one's going to be all the minus ones. If I were doing this all the time, I would probably go through the trouble of making a script that will handle all this automatically. And just be it should have 8 altogether here. 1, 2, 3, 4, 5, 6, 7, 8. So it looks like we got them all for the ones. So this object is going to be centered at the origin, and we'll scale it accordingly after the fact. So the next one is 0 plus minus 5 plus minus 1 over 5. And that'll be 4 of those. So you have 8 possibilities here, but 0 is only one possibility. There's no such thing as plus 0 or minus 0. So it's 2 times 2 is 4. So we'll have 4 of these. We have 8 plus 4 plus 4 plus 4. So 8 plus 4 times 3, or 8 plus 12 equals 20. So it's 0 plus or minus 5 plus or minus 1 over 5. That was it, those 4. Okay. And let's look at the next one now. 1 over 5, 0 plus or minus 5. Go ahead and save this. Minus that minus and equals always gets me. Okay, I think these are the 4 that we need for this little section. Now we've got 8 plus 8 is 16. We've got 4 more to go. And that's going to be 5, 1 over 5, and 0. Alright, so that should be, we should now have a list of these vectors. And let's see If that worked as expected, let's save this. Let's add our pass is a Python keyword. It just means do nothing, skip right past it, and it's a good place to put a breakpoint. Yes, and we'll run it. So now let's take a look at our vectors, our vertices list, and we see a list of these vectors, and it all looks pretty good. We've got 20 altogether, beginning at 0, ending in 19. So we're on our way. Continue to get on out of here. And the reason to import FreeCAD is to better log information here in the report view. And we can do that. Let's create a little function called log, def log message. And that'll be FreeCAD.console.printMessage. I think that's a capital. We'll add that /n there is the new line. I have this configured to automatically load in changes made in FreeCAD. So log so this is going to call that log function, and we're going to convert this number to a string. That's what str does. And len is a built-in Python function. It gives you the length of this parameter, which is vectors. So this should print the length of the vectors into the Python console when we run this. Oh, it's vertices, not vectors. Vertices. Alright. The vertices is the name of the list, and it holds a list of type vectors. Looks like a crash FreeCAD. Crash FreeCAD. Let's try again. Once it comes up, we can go ahead and attach, and here's a reattach. I'm not going to bother recovering that. Go back to macro. Bring it up into the editor. Not sure why log caused that problem. So that's working. Let's reattach now. Reattach the process. Run it again and see if it crashes again. Okay, we need to add our DD object back in. It should have recovered that file. And this will be a float. It's called scale. and the value is 1. Now let's run it again. Okay, now it printed out 20. I don't know why it crashed it, but save and save often. Save your file and save often. Okay, I'm going to put a pound in front here, and that means this is a comment. Alright, now, now that we have our list of vertices, all we need to do is add them in as part.vertex objects. And we need to import part and part GUI for that. And let's just do it in FreeCAD using the graphical user interface and see how that does it. And we'll just do the same way. So here we'll add our point object, just the default. So we see down here, app.active document, add object. And I'm just going to copy this. I don't care about this bit. Setting the placement. And we'll do that as a little function. Def midpoint V. And I just pasted this in from the console. Easy peasy. So now we've got our vector in here, and we can set this to v.x, but I want to really do it a different way because I want this to be parametric to the scale object. So let's see. So look how that worked down here at the bottom. Set expression is used. And these are strings. Now instead of saying get document unnamed, I'm going to use active document. So I'll get whatever the current active document is. And I don't want to use Vertex because that might have a different name by that point. So this will be active object. And instead of times 1, it's going to be times so this is going to give us whatever the current value of v.x is as a string into this expression. And we'll do the same for x, y, and z. So I'm going to Control C, copy this. Control V, paste it back in. That'll be the y, and this will be the z. Now, Visual Studio automatically converts tabs to spaces. So we can use tabs in here. Just keep in mind, if you're using a different editor, it might not do that for you. So this will be Y. Copying and pasting code is considered bad practice, but just about everybody does it, including yours truly. Just got to make sure you get them all. Leave any out, it's not going to be good. Alright, so this is going to make our point objects parametric to that scale factor. And now we just need a little loop here to add them all in. So I'm going to say for V in vertices, what was it, make point V. Anytime you add an object, you should recompute. This is the same as pressing F5 to refresh. So we'll add it, we'll make sure to recompute, and the new object that you just added is always the active object, the object that's currently selected. So hopefully this will give us those vertices, those vertex objects. Let me delete this one, and then let's save this document in case we have another epic failure. Documents, I'll just call it alright. Now let's run this and see what happens. Alright, so we have our vertices, and they're all look like they're all in the right spot. Can you see them on your screen? Let me select them so they show up a little better. So that looks good. We can have one more recompute here. And I think that's it for the macro part. Next of it, the rest of it will be done in a GUI. Now, let's do a little test here. So if we had a sphere of appropriate dimensions, each point will be on that sphere. And this radius needs to be square root of 3. For this particular scale factor for that to work. So let's enter that here, square root of 3. F5. So you see each of our points is on the surface of that sphere. And now if we change the scale to 2, they're bigger than the sphere, you see that? So we're getting our parametricity. The sphere is not set. It's not set to link to the DD object. I just wanted to show and to test that the parametricity has been achieved. Alright, now what I'm going to do is delete this sphere, and I'm going to select all these objects and create a compound. So this is like a fusion, except it's one object that we can deal with as a single entity. Now let's go to part design. This is running a little bit longer than I would like, but I had a lot going on there. So we're in part design now, and we're going to create a body. We'll select the compound and then create a shapebinder. And then we'll hide the compound. So this is how you reference objects outside of a body, is you create a shapebinder and you reference the shapebinder. If you try to reference an object outside the body, you're going to get link out of scope errors or warnings. Alright, and now this is the tricky bit. We need to select 3 of these that are on a plane. These 3 will work. And create a datum plane. And it's mapped automatically, plane by 3-point mode, with these 3 pre-selected vertices. So our datum plane is going to be at the right angle for this particular pentagon. With the datum plane selected, we'll create a sketch. The sketch will be automatically mapped to that datum plane. And I'm going to close it and select map reversed, so that I'm looking at it from the front instead of from the back. So you see these 5 dots are the 5 that we need our pentagon to lock onto, but we only really need 2 of them. So I'm just going to select these 2 and create a link to external geometry to those two vertices. It gets a little easier after you get the first one in. And now we'll make a pentagon. And just put it out here somewhere off to the side. And select one point from it and this point here. And do the coincident constraint. And now another point adjacent to that one, which would be this one if I can grab it. It needs to be on that point. So we got them both selected there. And now our sketch is fully constrained, and it's lined up exactly with those 5 points, I hope. Alright, now I'm going to hide this datum plane. And let's do another one. So we want one that's going to be on the same plane as one of these edges. Looks like these 2 right here. These 2. And see if we can pre-select that edge, that point there. And let's make a datum plane here. Have a look at it. Okay. Select the datum plane, create a new sketch. It's going to be these. Probably hard for you to see. It's hard for me to see. It's going to be these three here. Alright. And make another pentagon. And we'll link and grab that point there. Let me hide this datum plane, it's in my way. You can switch back and forth between the tab. It's not want to let me grab. Okay, now it is. I was backwards on it. So one there. And one of these you see is the center of the circle. This one needs to be right over here. And this one needs to be on this point. On this point. Alright. Select a couple of these points here. And one of the others, which would be this one, should do. Create a datum plane. Alright. Select it here, create a sketch. And let's create some links. That one. And this one. Kind of hard to see which point you're working with here. And let's put this point here. What happened to my pentagon? Always remember you can undo if things go unexpected. Alright, so now we're locked in. And hide this datum plane. Are you bored? Should I pause and skip ahead to making all these? Say something. Alright, those are on that plane. Create a datum plane. Okay. Select the datum plane. Create a sketch on that plane. It's getting a little bit easier, I think, now. Alright, let's see now. Add another Pentagon. The reason I add it out here away from anything, I don't want this automatic constraining to constrain it to any of these edges here. That's the reason for that. Coincident constraint there. Coincident constraint there. And we're done with that one. The next one will be using this one. I need to hide that datum plane there. Let's see, this one, and this one. If I can get it to, yeah, it looks like I got it. Nope, that's the wrong one. I don't want that one, I want this one. These 3 points. Alright. Select the datum plane, make a new sketch. And we'll link to external geometry. Any of these 2 points, it really doesn't matter. These are a little bit lighter color, whiter color than the others. So I can tell if that's not showing up on your screen. And hide this one. So we're moving right along. A little bit of a tedious process. This one, and this one. And make the datum plane. Now we could just map the sketch to those points too. For this one, I think I need to reverse the mapping. I guess it's something to do with the order of selecting the points. Alright. And we'll create our external links. One here and one there. Even though there are 5 points, we only need 2. Because you're locking onto the plane that you're attached to, as well as these 2 points. We'll hide this datum plane. So we basically got half of it made at this point. Select these 2 and that one. That's all part of the same pentagon. And I'm going to reverse map this one. And external links. That point and that point. Or could have just linked to this edge also. So I got that one while making it. And this one Let's see if this is going to work. Yeah. Close that sketch, hide that datum plane. Alright. This point, that point. Kind of tilt it around and get different perspectives and make sure you got the right point selected. And that one is going to need to be reverse mapped as well. You can do it from the back side, but sometimes it's hard to get at your points. So that turns a little wider. So that's the edge I'm working with. Missed it. There we are. Let me clear that error. So if I get another, it'll catch my attention. Notice I don't even need to set the radius of the pentagon because it's set automatically constraining to these points. Let me hide this datum plane. So we've got 7 sketches made and we need to make 12 altogether. This is a 12-sided figure. The last one is the tricky one. Because it's hard to see where you need it. Alright. So that looks good. Let's create a datum plane there. And a sketch on that datum plane. And it looks like it's the reverse mapped also. Alright, use these. It doesn't matter, any of these 2 points, any of these 5 points, any 2 of those 5. So actually this is sketch 9. So we have three more to go. I'm going to reverse map that one too. Some of you are probably saying, oh, there are better ways to do this, and probably there are. There are always multiple ways of doing things in FreeCAD. But I want to show you doing that script, and I want to show you using these datum planes and shapebinders. So that's 10. We have 2 more to go. Okay, so one's going to go here, and one's going to go here. But once we place this one, it's going to be hard to tell the next face that needs to be done. So let's figure out how to get back to this face. Let's view from the bottom here. Bottom and then down. Front and then left. Okay. Front, left. Front and left twice. And it'll be here in the front. So right. It'll be the one right here. Don't let me forget that. Okay. Datum plane there. I'm just going to leave that datum plane there. That way I won't forget which one it is. That'll be a better way. And now I can do this one. And a datum plane for it. Okay, hide this one. Go back to this one. That's a better way to do it. And I'm reverse mapped here. Alright. Now, create our links to external geometry. And use these two. So this is where we need this last pentagon. It looks like there's one there, but it's not. All these edges are from other pentagons. Uh-oh, missed it. There we are. And the last one, finally, huh? Clear that here out. Alright, so here's our shell or set of sketches. And if we put our sphere in there, just to look at it, bump the microphone. Square root of 3 times scale should put us on those points. And it does. And if we modify our scale to test that, see all those points remain on it. And we can make that rounded. There's a picture of the rounded one you see here. You could do that. Use two bodies, one for the sphere, one for the thing we're about to do. and take the common between them, and that would produce this object, I believe anyway. I'm going to delete that sphere. Now let's start padding these in. We use the pad operation. This one needs to be reversed. And the distance should be let's see what that does. As long as we get about halfway in for each one, it should give us a good solid. So I'm going to Control C, copy this little formula. We'll go to the next one, pad it, Control V, okay, that looks good. Pad this one, Control V, okay, we got an error, and let's look at this error message. Failed to recompute. Result has multiple solids. This is not supported at this time. So what's causing that is, you might remember I told you in an earlier video, one of the limitations of the part design workbench is you must have one contiguous solid at every step of the way. So what was happening is it's extruding this in the wrong direction. So if we change it to reversed, it'll now, all of it will intersect. And again, the same here, reversed. So, did I remember to put the scale on the last pad? Yeah. This could be automated too with the script. If you were making these all the time. Won't let me click the edit. Okay. And this could be made into a parametric object, primitive, not too difficult to do. Let's pad this one. Because we're going in about halfway, they all should intersect pre-existing pads. So the order of padding doesn't really matter. So we've got a few left to go. Too bad we can't just select them all and do them all in one go. You can do that with extrude in Part Workbench. But not here, I don't believe. Almost there. Nope, forgot to reverse that one. One left to do. That's an interesting object, isn't it? And you can turn this off to speed things up, but I find it very handy to have this update preview set to true. You don't have that feature with the extrude operation in part workbench, but you can undo, apply and undo. So this looks like a pretty good object. We can do the check geometry in part. Let me save it in case this crashes on us. It looks good. And let's look at the shape content. So we should have 20 vertices and 12 faces, which is exactly what we have. One solid. So that's outstanding. Now we made a die out of a tetrahedron, and we can make a die out of this too. It would be a 12-sided die. Might be fun for some games of chance. But this video is way too long already, so we're not going to do that. Not today, anyway. Now, there are some interesting properties of this. The cross section is a hexagon. The golden ratio is an interesting property that relates to this object. It's one of only 5 platonic solids. The one we're most familiar with is the cube. Each side is a square. The tetrahedron we made already, each side was an equilateral triangle. This one has a pentagon. I think it's the only one with the pentagon. The others are all triangles. But that's going to wrap it up for today. Hope you learned a few things, and hope you were entertained and not bored too much. I probably should have paused in some of those areas and completed it off camera, but I didn't. So that's going to be it. Thank you for watching, and have a great day.